Good morning to one and all present here. Meet our today's expert, Dr. Neeraj Kumar Singh, sir. He is a PhD in animal biotechnology. Currently, he is associate professor in College of Veterinary and Animal Sciences, Kishanganj, Bihar Animal Science University, Patna. He is working as an associate professor in Kowas, Kishanganj since June 2023. Previously, he was working as scientist in College of Animal Biotechnology, Guru Angad Dev Veterinary and Animal Science University, Gadwasu, Ludhiana, during October 2011 to June 2023. Dr. Singh received his BBSc and Animal Husbandry from Maharashtra Animal and Fishery Sciences University, Mapsu, Nagpur, and MVSc and PhD in Animal Biotechnology from ICR Indian Veterinary Research Institute, Ijat Nagar. He has published 30 research papers in peer-reviewed journals with average NAS rating more than 8 and 2 review articles, 4 book chapters, 3 popular articles, and 5 practical manuals. In 2023, he has honored by National Academy of Veterinary Sciences as member fellow. His areas of work are molecular virology, vaccine development, diagnostic and in silico viral host pathogen interactions, etc. On behalf of organizing committee, I welcome you, sir. Now over to Neeraj Kumar, sir.
Thank you very much, Dr. Sonam. I'm here, Dr. Neeraj Kumar Singh. I'm Associate Professor at College of Veterinary and Animal Science, Kishanganj, Bihar Animal Science University, Vasu, Patna. Before that, joining this Kowas Kishanganj, I was scientist at Gadwasu, Ludhiana. There I was working in the College of Animal Biotechnology. My area of work was mainly on biotechnological aspect, mainly molecular virology. I have been also involved in the dairy science college there in Gadwasu. So when I get the opportunity to present myself on application of biotechnology in dairy science, I felt very happy that these biotechnology and dairy science two are not new for me. Previously, I was working there during my Gadwasu stay there. So really, I am very thankful to organizing committee who has given me opportunity to present myself on behalf of this team. So this biotechnology, as we know, biotechnology, this is the most emerging field in the field of life sciences, especially in teaching research related activity. Nowadays, biotechnology has important roles in each and every aspect of the life sciences. The biotechnology having several definitions. Among the several definitions, I have here represented in most simplified way that biotechnology is the use of biology to develop new products, methods, and organisms intended to improve human health and society. So this is the brief history. This is the history of the biotech. This is the definition of biotechnology. Now history. Biotechnology have huge history. So history of biotechnology has been divided into 3 groups. One group is there pre-BC history, before Christ history. Then after Christ, there are another 2 category of history. That is, one is from after Christ to 20th century, and third one is 20th century to till to date. So biotechnology having huge history. It has been divided into 3 parts. The first part is before BC. As we know, the people was having practiced use of biotechnology in prehistoric time also. During 500 BC, the Chinese was using moldy curd, which was having some antibiotic properties to treat boils. During 2050s BC, the Greek was having practiced to rotate the crop. They were not knowing what is behind that, what is the main principle behind the rotating the crop to increase the soil fertility, but they were unknowingly using the biotechnological practices. Actually, by rotation of the crop, the nitrogen content of the soil was increased due to some leguminous plant. During 100 BC, the Chinese was using the chrysanthemum powders as an insecticide for agriculture purpose as well as for the animal husbandry purpose also. Now, the second part of second historical part of biotechnology, that is after Christ to 20th century. During this period, in 1590, Jenner was first of all discovered or invented the microscope. In 1663, Hooke discovered the cells. In 1675, Leeuwenhoek discovered bacteria and protozoa. In 1797, the Jenner, who is considered a father of vaccinology, was given the principle of vaccines and developed a practice to control the smallpox, which was havoc during those times. In 1802, the first time the term biology was used. In 1855, the E. coli bacterium was discovered, which is the most commonly used in field of the biotechnology nowadays. In 1855, Pasteur has used the yeast for fermentation purpose. The Pasteur also given the principle of fermentation as well as the pasteurizations. In 1883, rabies vaccines was developed. Then the third historical aspect of the biotechnology is that is after 20th century. After 20th century, what was there? In 902, immunology was first used. Terminology was first used. In 906, the term genetics was used. In 915, the 1915, bacteriophage was first of all discovered. In 1919, the Carl Erke, who is considered as the father of biotechnology. Again, I'm telling, Carl Erke is the considered a father of biotechnology, who was used the term biotechnology. Actually, Carl Erke was an engineer, mechanical engineer. He used low values garbage material to produce high value proteins, especially in the pig farm. He was considered as the pioneer of biotechnology, and he is considered as the father of biotechnology. In 1928, Fleming discovered the penicillin. 1938, molecular biology term was used. In 1941, genetic engineering was first in practices. In 1944, the gene term was it has been proven that the DNA is acted as a genetic materials. During 1954, the cell culture technique was first in use. In 1956, fermentation technique was perfectionized. In 1977, genetically engineered bacteria was developed, which was used for the production of human growth proteins. In 1978, side diachromate mutagenesis was first time developed. In 1979, first time hybridoma technology and monoclonal antibody production came in practices. In 1981, first genetically engineered plant was produced. In 1982, genetically engineered bacteria, which was used for the production of human insulin, that is humulin, came in existence. In 2000s, a rough draft of human genome was completed. If I just explain what are the different main discoveries or main inventions happen in last 10 years, then it will take another 5 to 10 hours. So I'm not here going any more about the historical aspect. So biotechnology is huge, beyond our imaginations. If you just put the term biotechnology in PubMed, you will get more than 10,000 entries in last years. So this biotechnology is the very big field, and it is lot of people are working on, and a lot of new inventions has been in existence since last 10 years. So application of the now question arises, if it is so important, then what are the different applications? Biotechnology having various applications in various fields, including medicine, agriculture, animal husbandry, food and dairy processing, and environment science. First of all, I am explaining medicines. In medicines, the biotechnology has been in practice for the development of new drugs, development of new vaccines, development of new diagnostics, creation of new therapeutic practice. The best example there. Initially, the first antibiotic was discovered in 1928, penicillin by Fleming. after discovery of first antibiotic, on an average, in 5 years, one new antibiotic was discovered. Every 5 years, new antibiotic was discovered. But when the biotechnological intervention increased nowadays, every year more than 300 antibiotic has been discovered or modified. Antibiotic has been created. This is due to this fast turn of the discovery of the new antibiotic can be possible due to the biotechnological interventions. Second things, as far as the medicine concerned, there previously for development of one vaccine more than 20 years. All we know about the COVID was reported first time in the 2022 March. At the end of 2020, that is within the 1 year of first outbreak, the vaccine was in existence, that Covishield and Covaxins. You know, the Covishield, the marvelous of the biotechnology, marvelous example of the biotechnology. Here the recombinant technology was used, in which one virus, adenovirus was used as a vector for delivery of the COVID-19 S gene. So with help of biotechnological interventions, the vaccine generation time, vaccine development time get reduced. Third example is the diagnostics. Previously, what was the diagnosis? Mean of diagnosis, simple by symptomatic diagnosis. After looking at this one patient feature, we can show, okay, this patient having this kind of disease, or some serological test was there. But due to the biotechnological intervention, especially the RT-PCR, this become the diagnostic test become the most sensitive and most specific. If we get the result by real-time PCR, if it is positive, then 100% is positive with high sensitivity, 100% sensitivity and specificity. Or if we are getting negative, that means it is 100% negative, without any doubt. Previously, the serological test was there. The serological test was there having a maximum 70-80% sensitivity and specificity. So with help of biotechnology, the diagnostic has been also improved, especially in the field of medicines. Then agriculture. As far as agriculture concerned, there, our population increasing day by day. And this increasing population need more and more food. Previously, the productivity of the agriculture was very low there. But due to biotechnological intervention, the not only productivity, but also quality of agriculture product has been improved. For improvement of agriculture product, the best example is there the BT cotton. Best example is golden rice. You know, as all of you might knowing what is golden rice. Golden rice is genetically modified rice in which the beta carotene gene has been incorporated. Due to incorporation of beta carotene genes, what happened there? That rice, which is full of a starch molecule only, now having carotene molecules also. So the persons who is consuming the golden rice have not facing any deficiency related with the vitamin A. Now, application of biotechnology and animal husbandry. Animal husbandry is also not untouched with the animal husbandry also. In animal husbandry also, biotechnology play crucial role, especially for the breed improvement, diagnostic, treatment. I will explain about the breed improvement in next slide there. Now, biotechnology also play important role in the food technology or dairy technology. So I will explain the next slide. Now, the last one is the application of biotechnology environment. As we know, day by day, our environment gets polluted. We need something which can control the pollution, or whatever pollutant available in the material should be removed from the environment. Two approaches there. You know, I think all of you might knowing the Pseudomonas putida. What is Pseudomonas putida? Pseudomonas putida is the oil degrading organism. Our India is importing every day lakhs of metric tons of the oil, crude oil, especially for petroleum. Due to import of the petroleum, there is a lot of seepage in the coastal regions. This oil seepage creates serious pollution in the ocean regions. This oil persist for the 10 years, 20 years, for decades. and cause harm on their local ecology. But after discovery of the Pseudomonas butida, which is having the property to destroy the oil molecules, now the whatever oil gets seepage there, that has been easily degraded, and the environment, ocean environment, is now protected very easily. Now the question is, how the biotechnology play roles in the dairy sciences? If we talk about the dairy sciences, there the two aspects is there. In two ways, biotechnology play important roles. First way is there to increase the productivity of milk. Second way is there the implementation of biotechnology in the milk and milk product to improve the quality of the product. The first aspect, how the biotechnology play a role for increasing the milk productions. I'm just enlisting the first I will enlist, then later I will explain each one. First, how this will improve the milk production. First one is, it is identifying superior animal at the early age, increasing rate of genetic improvement, detect abnormality, improve understanding of mechanism of genetic control, determine parentage, transgenesis, and improve nutrition. Now I explain you each one of this one, 7 points. Identifying superior animal at the early age. Normally, what is the in practice to identifying the superior animal? When animal is performing, then only we can say, okay, this is good performer or this is bad performer. So only for in case the milk production is concerned, there we can identify the animal with high productivity only after achieving the maturity and first calving. But with the help of biotechnological interventions, we can identify even in the embryonic stage of animals that this animal will be high yielder or low yielder. So biotechnology, with the help of biotechnology, we can identify the animals at the embryonic stage only. Second one is the increase the genetic rate. So if we know the possible outcome, possible performance of the animal in the embryonic stage, we just select only the high yielder embryo only for further pregnancy, for further pregnancy. Otherwise, we have to just adopt the practice of the abortions for the low yielder embryo. So by this means, the genetic improvement rate can be increased. Previously, suppose I'm just giving you one example there. Previously, if we have one herd which was having average milk yield 10 liter per day. If you want to improve genetic improvement from 10 liter to 11 liter, it will take minimum 20-30 years of the selection process. But with the help of biotechnology intervention, now this can be possible to improve the genetic potentials within a years, even less than that one. Then they detect abnormality. During the pregnancy time itself, we can identify whether this animal is there that is having some abnormality or not. Simply what we can do there, we have to go for the amniosynthesis. So amniotic fluid is there, we are having some fetal cells are there. By karyotyping of the fetal cell, we can identify whether animal will be healthy. Whatever animal will produce after parturition will be healthy, normal or abnormal. Fourth one is improved understanding of mechanism of genetic controls. This is a little bit tough to understand to all of you. Now is the determine the parentage. Parentage means the animal is there, whatever animal is there, what is their parentage history? By this help of the DNA fingerprinting or by help of the biotechnological intervention, we can identify the parentage. Sixth one is transgenesis. What is transgenesis? Transgenesis means animals which having some genetic source from some another animals or some other organism. So by means of transgenesis, by means of biotechnological intervention, transgenesis has been achieved for producing some specific product, especially in form of the bioreactors that improve nutrition. What is there nowadays? Animals are there which having human microorganism, normal human microorganism, which is used for the ruminal digestions. With help of the biotechnological interventions, we just genetically manipulate the human microorganism. So animal can maximum efficiently use the whatever nutrition they are present in their fodder or food. This is one aspect. This all 7 is one aspect of the application of biotechnology in the dairy science, especially for the enhancing the milk productivity. Now, second aspect is there. Biotechnological intervention in dairy science is that how biotechnology contribute for enhancing the quality of milk and milk product. So biotechnology enhance the flavor, aroma, consistency, shelf life, and nutritional value of the milk and milk products. Previously, people were using for preservation purpose for preservation purpose. Previously, people was adopting two practice. One is physical practice, another is chemical practice. Suppose physical practice, physical practice included for preservation, keeping the food material or keeping the dairy material at low temperature. Chemical practice is there, adding some preservatives. Many preservatives are there, has been in practice there in the dairy sciences, which having serious adverse effect on health, seriously deteriorate the quality of the product, seriously alter the taste of this one product, seriously alter nutritional integrity of the product. With the help of biotechnology, one important product, that is bacteriocin, has been developed. This bacteriocin is used as a biopreservative purpose. This bacteriocin is antimicrobial peptide. This peptide by the lactic acid bacteria. This antibacterial peptide act on the cell wall of other milk and milk product spoiling bacteria. By acting this antimicrobial peptide on the cell wall of spoiling bacteria, the spoiling bacteria growth get controlled or completely destroyed, and the shelf life of the product get increased. The bacteriocin has been commonly nowadays used in the yogurt and cheese preservation purpose. It is used either on the food surface itself or on the surface of packaging material. By this means, the preservation of dairy product get improved without altering the chemical and nutritional value of the dairy product. Now, third approach is the probiotic. I think everyone is related with the all of you are related with the dairy science. You know what is probiotic. The literal meaning of the probiotic is for life. Nowadays, probiotic is the huge market of probiotic, and biotechnology play a critical role for development of new probiotic with enhanced its nutritional and beneficiary values. Previously, lactobacillus and bifidobacterium was the most commonly used probiotics, but nowadays also bacillus, pediococcus, and few yeast has been used for the purpose of probiotics. This probiotic has been used for the yogurt, cheese, ice cream, sour or fermented milk, baby formula, or all of you know about Yakult. The Yakult is one of the best examples of the probiotic. This probiotic is used for the either for the quality benefits of the product, or better flavors, for better aroma and better texture. This probiotic also have health-related benefit, especially it act as a immunomodulators. It acts as a mucosal barrier functions. It is used for the persons who is having lactose intolerance. It maintains the gut flora. Now question arises, how biotechnology play roles for in the probiotic? With the help of biotechnology, we can select the best probiotics. We can modulate, we can change the genetic materials of the probiotic organism. So can probiotic organism give maximum benefits. So these are the means by which the biotechnology play roles, especially by means of probiotic. Now, third one is there, enzyme technology. You know, there are several enzymes has been used in the dairy sciences. These enzymes have been produced by genetically modified bacteria. Some example of the enzymes include phytase, lipase, chymosin, microbial rennet, protease, beta-galactosidase, etc. are some important enzymes which is commonly used in the dairy science, has been produced by the genetic manipulation after several bacteria, including Aspergillus niger, Aspergillus oryzae, E. coli, and other microorganisms. Now, the most important thing is the recent development of biotechnology, especially in the dairy science, that use dairy animal as a bioreactor. What is bioreactor? You know, reactor means what? Where something is producing there. Bioreactor means what? The biology, the live animals
as used as a factory. Many enzymes, many medicinal values biomolecules has been produced through the genetically modified cattle's milk. The best example is their blood clotting factor 8, human insulins. So what happened there? This thing is there that the genes for the blood clotting factors 8 has been incorporated into the mammary tissue in downstream of the ovine beta-lactoglobulin promoter. Due to incorporation of these genes of the same important biomolecules, especially blood clotting factor, human insulin, or nowadays also recently, just a few days back, I have read one the journals where it was there that silk fiber has been produced by the cow milk. So silk fiber gene, that is fibron genes, has get incorporated in the mammary tissue under control of beta lactoglobulin promoter. Whenever the milking started, this promoter get on, like switch on our house having the switch now switch, which having on and off option. When milking started, this promoter get on, the gene downstream of this promoter, that is beta lactoglobulin, sorry, beta blood clotting factor, human insulin or fibron gene get on, and this protein get produced there and secreted through the milk. After secretions, after getting the milk, we get harvest these molecules and use for a specific purpose. So by this means, biotechnology also contributed indirectly in the field of dairy technology, especially for medicinal purpose, for industrial purpose. Now, application of biotechnology in biotechnology, apart from whatever I have discussed, biotechnology also have important role in the dairy science by means of pasteurization, by means of homogenizations, by means of microbial count, plastic packaging, non-technical processing, hazard associated critical control point, edible form, biofilm, functional food, policy reform, fermentation technology. So biotechnology play important role in the field of dairy science. Of course, dairy is a small sector of the animal husbandry, but biotechnology also have crucial roles in the field of dairy sciences. Apart from this, that I can conclude my presentation that what are the application of the biotechnology, especially in the animal science and dairy sciences. So these are the some important field where the biotechnology play important roles. Not only dairy science, but also in the meat industry, other product development, biotechnology play critical roles. So these are the some important aspect of the application of biotechnology in the field of dairy sciences. So this is brief about my presentations. So now I am welcoming all of you to please discuss whatever I have given. That is the all highlight I have represented there. So now I'm just opening this field for discussion. So whatever query is there, whatever new things is there, that can be discussed among us. Please. Hello. Shonam. Hello. Hello. Please query, please. Is there any queries? Please discussions. Now I'm opening this one for discussion. Hello, Shonam. Shonam, are you listening me?
Okay, Dr. Neeraj, uh, now the session is open for the discussion. If participants, if you have any query, you can ask.
So I have just taken 30 minutes, complete 30 minutes for my presentations. Another 15 minutes is there for query, any discussion, any suggestions, whatever you want there. I'm available here, please.
Okay, I think there is no query. Sonam, please over to you.
हो गया मेरी तरफ से presentation हो गया कोई भी query है please. What is the latest trend in the using whey proteins hydrolysis to create a new functional food and this one enhance the one question, one query is there about the functional food. Actually, I'm not the expert of the functional food. I know the biotechnology interventions. So someone concerned with the functional food related topic. So please, what I'm just concerned with the biotechnology. If you know want to know about the genetic manipulation, about the transgenesis, about the probiotics, microbiology related topic that I can explain very nicely. But functional food, I'm not the appropriate person. I think dairy science persons, Sonam or others are there. They are most appropriate for the answering. Sonam, can you explain there? The one question has been raised there. What is the latest trend in the using the whey proteins hydrolyzed to create new functional food and beverage with the enhanced health benefits?
Sir, mainly whey protein hydrolyzed is mainly used for those people who is not who is very susceptible for protein digestion. So it is mainly used for some geriatric food in preparation of geriatric food to deliver proper nutrition, but in a pre-digestible form. So there is a new trends to prepare a geriatric food, and another one is in the uh, like for preparation of baby food for not for neonates but more than 2 years or 2 years children's.
Okay.
I can add into this, Dr. Sonam.
Yes.
Whey protein hydrolysis. After hydrolysis, the functional group are exposed to the surface and its functionality increases. So whey
Yes.
protein hydrolysis has more antioxidant, immunomodulatory, and antihypertensive effect, and many more health benefits as compared to their parent whey proteins. And
Yes.
it also increases the functionality in terms of the product quality also. It increases the you can say whipping property, also increases the emulsifying property of the ice cream also. So it has both the health benefits as well as the techno-functional properties. This is all about the whey protein hydrolyzate.
How now another question is there? How biotechnology is being applied to develop self-stable fermented dairy product with the active probiotic and offer the extended shelf life? Already, I have told there are the now lactic acid bacteria there which is producing the bacteriocins molecules, which is which is having anti microbial peptides, which is considered as antimicrobial peptide. If we are using that antimicrobial peptide, especially bacteriocins, so this product have this bacteriocin having its own some shelf life that is maximum 7 or 10 days there, without affecting any adverse effect on the taste, quality, chemical property, and nutritional value. This bacteriocin increase the product shelf life. So this is nowadays commonly used for the. So bacteriocin is one of the good example of the biotechnological product which is used for the preservation, especially in the field of dairy sciences. Okay, any query, please? Another 4 minutes is there. I have given slot of 45 minutes. So now it's 11:41. So another 4-5 minutes there. Whosoever want to ask any query, please.
Participants, any queries? I think so. There is no queries. So we should
Shall I
end the
shall I
session.
leave now?
Yes, yes. Okay, sir. Thank you very much for such an insightful session.
Thank you, Shanam. Thank you, Shanam. You have given me the opportunity. Moreover, you have pre-pondered this my schedule. So a lot of assignment I am having today from our university side. So now I can give my full time to university for whatever assignment I have been given.
Thank you, sir. Thank you. Thank you very much, sir. Participants, you may leave now.